We say that we dream our paintings. I dream my paintings, and I paint my dreams. So whether it's your home or it's your industry, the painting is associated with primarily we know with in the industry is with the corrosion, and the corrosion is associated with the process safety. So the topic of the discussion is the painting, whether it's a painting or it's a coating, associated with what are the different corrosion mechanisms we have, and thereby the failures which happen because of this non-compliance is the process safety, I think, which is the need of the hour. And we are in the belt in and around Bharuch, where I think I don't remember that if there is any industry which is not handling corrosive chemicals. We are in a specialty zone, in fact. I mean, all the players are handling one or more specialty chemicals which are either so precious and thereby the ingredients are corrosive in nature. So this topic becomes a point of discussion and always a challenge for all the operating crew. So, I mean, taking this forward, I'll take my question with Mr. Parag. First of all, that we'll start with what are the corrosion failures and challenges we face on day-to-day industry in specifically related to the specialty chemicals and thereby the challenges for the process safety. Yeah.
Okay, good evening. Here the corrosion, when we are talking about in this region, every industry and everybody is facing, and there are all different types of corrosion. So in our chemical industry, we are facing like a different types of corrosion, uniform corrosion. Then there are a specialized corrosion also like beating, or the spot corrosion is also there like galvanizing corrosion. So if we go into the details, why corrosion happening and how to protect this corrosion, but everything is depend mainly with the operation and the production. So when we go into the operation and the production, process safety is also must, and corrosion affect the process safety. But somewhere why process safety happen? Because whenever we start a new product in any of the specialty chemical business, we have to go for a selection of the material. And if we select a wrong material for any process, then there may be a catastrophic incident or accident may happen. So in the process safety also, when we go for any new product, selection of the material is the most important thing. And we have to go step by step, how we select the material. Like there are a lot of ways are available. Coupon tests are there, because all materials are available in the market. Or in a specialty, like I'm coming from Deccan. So Deccan is mainly in the custom manufacturing business. So here we are not building a plant for the product. We have a plant and we map the product in the plant. So in that, this corrosion or the selection of the material is very, very important. And in that, if anything happens, then the process safety is the first part we have to take care before selection of any material of construction.
No, sir, once the corrosion, we know the product is corrosive, there is a corrosion going to happen at a certain rate. We have a lot of expectations from the equipment suppliers. So the equipment supplier has some obligation, though my experience says that we do specify the material of construction and a lot of things, but we get the equipment, still it fails. So what do you feel are the expectations from the suppliers of the equipments, and what we face in reality?
Yeah. Good evening, everybody. Yeah, I am. Hello.
Yeah.
We are working in this industry, and I am also working last 20 years in the agrochemical. That is, we can say highly. Whenever we are designing the plant and we are starting the equipment designing, initially starting from their point of view, when we are talking about the manufacturer, what take the precaution take the manufacturer during the manufacturing of the equipment. So whenever we are giving there is a compatibility with the materials only. But now the day it will take the when we are starting from the manufacture, when manufacturing the equipment, yeah, structure, it will regularly inspection require. There is a no rework during the manufacturing. First point, there is a no rework during the manufacturing or no defect during the manufacturing. At the end of the manufacturer of the any equipment. That is the first we can say. Now another say we can solution, whatever we are selecting of a material of the equipment. So we are high corrosive resistant material we are selecting during the designing. And the same material the who are manufacturer the equipment who are take care there is a take care of the that equipment ki high quality resistant material they are using the manufacturer of the equipment. Second, then the quality control at the end of the manufacturer. The inspection of the each and every stage, the quality of not check during the first primary stage when we are selecting the MOC, then they are first part of the energy, we are right choice of the equipment, then we are whatever they are using the fabricator, there are work, there is using the right welder, welding quality, we can say. There is a, what is the equipment they are using during the manufacturing. They have a really a right technology for manufacture the equipment or something. They are not doing the manually work over there, placing like. So they have some software over there that we are selecting during the equipment manufacturing or structuring. That will also help them during the, yeah. Another, there is a, we have a new technology during salt spraying test is there. The where we are using this equipment, yeah, what process we are using during this equipment in our plant, so that we are predefined, and let's we check there is a salt spray test, there is a equipment available and lot of lab is available, so we can find out the right MOC of the equipment, and that will be help us for the long time. And another, not last list, but we can say during after the manufacturing they are doing the rear routine cleaning during the manufacturing, right color painting over there, they are doing that. It is not, that is a really requirement at the end of the equipment manufacturer. So this is will be helpful. Another, whenever they are storing their equipment part, they are storage, this is another even atmosphere, in the corrosion atmosphere. So long term it is affect our equipment also. So it is better is store the whatever part using in the manufacture of equipment is stored better in the better atmosphere, good condition, and all the good condition over there. So that will be help us for the equipment long term selection or manufacturer take care this all the things. That will be help us over the all over the industry to protect from the corrosion.
So we know that for handling a particular corrosive chemical, there are multiple materials are available in the market, whether it's a PTFE, we talk of PFA, we talk of glass line and all that. At the end of the day, the key is to run the business. And to run the business, it's the bottom line and the cost, which is very important part of it. So Mr. Parag, what do you say that, handling, putting a asset, putting a plant, where the cost control is the key, right? What do you say that the selection of the material and appropriate material for that product or the molecule is the key? How we offset that economics, integrity, and the process safety? All the things are to be met. So how we address that? If you can highlight a bit on it, yeah.
Okay. So what is correctly mentioned, there are a lot of materials available, and all materials are good also. Like normally when people say, yes, this process is corrosive, we'll go with HC22, HC276. Yeah, we can say titanium mud coating is available. But this material, we have to think about cost part also, okay, whether really other material is suitable for this process or not. So whenever we develop the process, first we'll go with the chemistry base, and from the chemistry we have to find out whether whatever intermediates or chemicals are involved, this chemical how attack on the different material. So for that, the best way is to do the coupon test. Normally all people knows also that before doing any of the process in the plant or selection of the material, we do the coupon test. And in the coupon test, we find out the weight loss. If weight loss is in permissible limit, then this material is suitable. So if we find out that, okay, these 2-3 material are suitable, then the cost will come into the picture. And apart from cost, delivery time is also an important thing. Like some of the material, I can say I required B10 reactor. But B10 reactor is having a 12-14 month delivery time. And at the same time, if HC22 available and both the material is suitable, and other reactor is available in 6 months with a low cost, then we have to select this material. But if you miss any of this point and we say that, okay, SS reactor is available within 3 months, so we'll go with the SS reactor, then it will create a major issue in process safety. Because process safety, if you bypass during the selection, then there may be an issue of leakage, cracking, or any incident in the plant. So apart from the cost, time of the delivery, and suitability, we have to select the best one which is suitable with a cost-efficient solution.
Okay, thank you. Yeah, Mr. Urvesh, I mean, we are talking of the assets. The assets are the key to the whole business, you know. Yeah. And we in the management, we used to say our machinery is our asset, but people are our assets too. But that, the second part has changed nowadays. They say that only the good people are our assets. Similarly, only the equipments which are selected appropriately and right way are the assets. The rest become the liabilities. Once they leak, they become the liabilities. So if you can throw a bit light on the what is the asset management, we look in the newly constructed corrosive operating plants and how to manage this whole thing in terms of IOW or econ and I mean a bit on it.
Yeah. So actually this IOW is integrated operating window is new for I think chemical industries, but in oil and gas is our normal way out for risk-based inspection approach. Before going to that, I just want to highlight some key features related to material selections. As I'm part of engineering, EPC business, part of EPC business, and I'm heading material corrosion. So we design almost entire refinery petrochemical complex in India and abroad. And I'm responsible for material selection and its uses till the design life which we want from end user, or we can say PMC. So just to highlight this, like material selection is based on a few parameters. One is temperature, other is pressure, concentration, and effect of external and internal corrosions which we think of. So normally when we think of any corrosion, these are the parameter which is important. When we say the corrosive gas like H2S or CO2, partial pressure plays an important role for designing the material. So it is not the only CRA is the material which we can select. There are many other materials in place. So like we have a sophisticated software which deal with process fluid, and from that we derive the actual metallurgy which is important. And in any industry, the most popular material is carbon steel. Why? Because it's easily available, cheap, easily weldable, easy to do any fabrication activity from that. Rest any material if you think of, from that to alloy steel to stainless steel to even duplex, which is a complex material as of now. But still we say that duplex is not the good material in terms of its handling. Because duplex, if it is a seamless or if it is a forged or if it is cast, it is a merit. But as and when the welding is involved, that particular properties may get compromised. And there are many failures in industry. Because of that, this metallurgy is not so popular. So coming to the forum where refinery corrosion is slightly different than chemical corrosion. So chemical industries are normally facing what they say is general corrosion or specialized corrosion. Though they didn't touch upon biological corrosions, which is normally there because of stagnancy of fluid and the water and other chemicals which they store. They have a biocide, and normally that growth is equally important for corrosions to understand. So this is one part where we say there are many corrosive type. There are 70 damage mechanisms as per API 571. And if you go across the API standard, it gives very insight about this. And if you want to still go more into this, then API 580 is the standard which you normally refer for in detail information about any damage mechanisms which you want to learn. So I just want to say in this forum that any material which you select is having its impact when you select the material. I just touch upon one parameter for thickness calculations because weight is our major concern for any material selection. SA516 grade 60 and SA516 grade 70. If you choose these two material based on the strength, you can play with the thickness. But yes, of course, you have to study that which process fluid you are handling. If it is water or any corrosive services, which is not affecting any corrosive species like H2S CO2, then you may choose this change from 60 to 70. And you can reduce the thickness to the large extent. If you say 100-meter column height weight to certain, you can reduce to 20 to 25%. So this is just beauty of material and metallurgist on roll for any company. So if you want to select proper metallurgy, then you have to consult metallurgist. And we are available across this panel, off the track and on the track, that how to select material is a challenge, but is more than science, is an art. And if you speak to Dr. Thanki, with his experience as my age, he started his career in 75 and I born in 75. So this is how we associated together so long. So just to see, we learn and we grow in front of his eyes. And this time we are setting the stage. So just to tell IOW and RBI, actually if you have a systematic plan in your asset management, then risk-based inspection is really a good tool to manage your asset. And it gives you periodically assessment of your asset. IOW give you the windows where you can and where you cannot, and based on that you have a proper planning for which you can take shutdown. When I was in lunchtime, I understand that in chemical industry, one of my friends says that they have a practice to put exchanger as a backup, not as a tube as a backup. So I was laughing to that is really fun that putting an exchanger as a step, means as a spare, which is really very crucial way of handling the inventory. So better to store or understand the corrosion damage mechanism rather than storing the asset. So if you concern metallurgists like us, we are here to help society and industry that if you choose proper metallurgy with proper selection of risk-based inspection and IW approach, you can minimize in terms of inventory. Last point which I touch upon is the change in metallic to non-metallic. Every time we are thinking that the best metal for corrosion resistance is zirconium. Why I am saying zirconium? Nobody touched upon that metal. But zirconium is the metal which is high temperature and high corrosion resistance material across globe in metal category. If you want any metal, this is the last metal. After that, no metal is going to withstand temperature and corrosion effect together. So better to choose non-metal, or you have options to use best coating nowadays available. So please come to us and chat for your problems, and we will try to solve based on our best knowledge. Thank you.
Thank you, Mr. Vala. Dahej is a location which is very near to the sea, and we have around 60 to 70, 80 days of rainfall, heavy rainfall. Now, the corrosion is not only important from the internal corrosion, but we talk a lot about the external corrosion. So, and this is a subject where most of the people do not pay any heed to it, and at the end of the day, they find that the external environment in Dahej, which is to some extent, I will say, it's more polluted than any of the ambient air available elsewhere. So it adds to a lot of corrosion from the exterior part. So, sir, Mr. Parag, what do you say that what type of the coatings or what type of paintings and the cost? Paintings are available now in the different varieties. a simple paint, a costlier paint, and then with some additives. So many vendors are there in the market which will supply you or which will tell you about how to protect the external pipe. So what your experience, if you can add a bit on it?
So frankly, I had never worked in Dahej till date. I worked in Ankleshwar, but Ankleshwar is also a more or less same pollutant from surrounding, same as Dahej. Only the Ankleshwar region is mainly the chemical corrosion, while Dahej is having a sea is nearby, so another moisture and other issue also there in Dahej. But rightly, if you say that yes, the corrosion point of view, first of all, if possible, go with the civil structure rather than the steel structure. So the corrosion point of view, like a structure corrosion, we can avoid. If not possible, go with the civil structure, go with the steel structure. But steel selection is that, along with MS, as rightly mentioned, go with the sandblasting, then after proper color and the coating, so that the corrosion can prevent in the steel structure. Regarding the piping and the other thing, we have to just see from, like as Ankleshwar region, there are a lot of HCl or the acidic gas or the fumes coming from the surrounding. So we have to paint the color, paint the entire surface regularly. And for that painting, as rightly mentioned, there are a lot of different types of paints are available. Acid-proof paintings are there. Then some of the corrosion resistance paints are also there. That will prevent the moisture ingress into the structure also. But painting frequency we have to maintain so that we can prevent the external corrosion.
So
Can I add something in this?
Yeah, please.
See, actually, I just want to touch upon the types of corrosive environment which we have. C1 to C5 is a corrosive environment, and IM1 to IM4 is for the immersion category corrosive environment services are there. Chemical industries are normally in C5 corrosive environment category. So selection of paint and the DFT plays a role. Also, there is one more technology in paint is when the temperature is high, DFT is less. And when temperature is less, DFT is high. So this phenomena is not known to many. And that too, if we say that universal paint is only one, any guess from audience? One paint, if I have to use minus 196 to plus 650, there is only one paint available which you can use. Anybody having idea about that paint? Is inorganic copolymer paint. Normally when you use this, it's excellent paint. But only problem with this paint is if you cross 300 micron DFT, there is a problem. It get crack. So, but it is having good resistance. But one problem is you cannot operate this to minus 196 or in the lower temperature range without its curing. Because it is not cured ambiently. It required heat up to 100 degrees C for 2 hours, and then after it can be cured. So those type of paints are also there, but yes, you have to do heating of those paint. It's not like you have to go for burner and all, but is by virtue of process, you have to select such paint. So that is one area, and the other area is when you see certain MIO category paint, where DFT is quite high, it is acceptable. So normally, whenever you consider any paint selections, you have to take these things in account. If you have a silicon-based paint, that DFT is 20 micron, and if you compare that with MIO, is one coat is 200 micron or 150 micron. So when somebody is putting the system in place for any corrosion resistance, you have to keep all this parameter in your mind, that what is a corrosive service and what is your temperature, operating temperature for your equipment or piping. So based on that, if you select a right coating, particularly when you see the system selections, that plays very important role for your asset management. Thank you.
Especially if you go in the Dahej or in this whole belt, you find there are a lot of plants which are operating on the batch mode, batch processes, especially the specialty chemicals. And we always say that what is the cost of corrosion vis-a-vis the life cycle cost as against the right material cost at one point of time. We play a lot of money. We spend very small amount of money to have a huge gain in the short term, but we always pay, a big cost for that in case of any failure or in the process safety. So it's a one-time life cost for equipment, whether you take the tantalum, you take the titanium, you take the nickel. People don't go for it, they go for the glass vessels, which break, and ultimately there is a loss of containment. So Mr. Thanki, I will come to you that, we believe that the world is moving away from the, rather I'll say the risk-based inspection, which requires thorough understanding of the corrosion, which people, with the great respect, I say that they lack, which leads to the failure. There is a loss of containment, and the consequences are nothing but the safety, health, environment, and the economic conservations of all that. So how to implement that concept that, in the longer run, we have a process safety in place, we have a right knowledge, and the cost-effective solution for the productive use of the product as well as the human life.
Thank you, sir. Thank you.
Yeah.
There are many questions, no doubt, in the field of corrosion engineering and corrosion control. But there are 2-3 axioms one should remember, that corrosion is a natural process. And we accept it as a normal word. But I think we do not know the heart of natural process. What's the meaning of natural process? Corrosion behaves as per the norms set by the nature. And what is that? 2 things are. Nature has got the consistency. Sun rises every year, billions of years. It's a nature. You and me inhale and exhale the air consistently. Our heart throbs throughout the last breath. There is consistency. That is one thing. Second thing, nature has got the thing of discipline. Sun rises not billions of years, but it rises at exact time. Even one throb in our heart is fine, but single one, we cannot do no more. Inhaling, exhaling, must have that. So, unfortunately, man has got the one very negative thing placed by nature, that we cannot be consistent. We are painting with the best selection paint, but we are not very sure that consistently it has to be inspected. Once you applied, you see after 3 years.
Even sir, add to it, we find that the painting is done, but the way the painting is to be done is more important than doing the painting.
No, rather, sir, more than that,
Yeah.
surface preparation plays
Absolutely, this
more
is
than
what I
70%
is the key.
key.
Yeah.
Like, sir, if you want to master language, you must have the cramming of the very tedious way of the grammar to be remembered.
Yeah.
You never like to remember the grammar. Unless you control the grammar, you can be a good communicator.
Right.
Like that, if you have the tolerance to accept the dust created by the surface preparer man. So 70% of the surface to be prepared like that. Correct. And we don't have that much of time, sir. That's why any good paint will not exist. That's why the saying goes, no, the bad paint can go very low if surface is good. That is first thing, sir. As you rightly telling that near our Dahej, Dahej is nearer to sea coast. So knowingly we are in the corrosive area. So you have to have the extra conscious than the man, those who are working somewhere in Ahmedabad or Nagpur. Right? If you have got the cancer, you cannot stop it by a simple tube. Right, sir? Yeah. Like that, Dahej, since I worked as a corrosion advisor with the UPL group of companies for about 2 to 3 years, and Dahej was one of the one plant was there. So what happens, no? That surface preparation is done, and at the end of the day, contractor completes the surface preparation under the supervision of non-corrosionist type of mechanical engineer. And next day they start painting. But during that condensation of the night time, again, flash rust takes place. And you'll be losing the body characteristic of the paint. So in a day, you have to have the surface preparation which can be completed that day along with the substrate preparation and following by the first coating. So we forget that thing, sir. And that's why we face the problem of, then again it is falling with the C5I. As per international code, C5I. And so you have to be very careful in that case. Again, no paint is without any porosity, because vehicle will go away. Finer material will remain there, and that will allow that moisture to get into. So uplifting taking place. So when you are doing this painting business at the sea coast, you have to be extra careful. Instead of talking of the best quality paint, surface presence should not be forgotten. That is what I.
And I believe that painting is a business in the industries which is left to no one's supervisions.
Right, sir. Right, sir.
That's a fact of the life.
Yeah.
And it's the painting guy, a illiterate guy is told to paint what he was told without even looking at the humidity level. Humidity is one of the control factors for that. People just do the painting till it starts raining, you know.
And sir, that's why, knowing this one, as the chairman of the CII Corrosion Management Division, CII Chandigarh, we have started Corrosion Manager course.
Right.
That means, irrespective of your specialization, you will become a manageable person who knows about corrosion. So mechanical engineers are supposed to know what to inspect when painting is done, like that. Electrical engineer, civil engineer, like that.
So sir, if you can add a bit on, based on your vast experience of last, more than few decades, what are the innovative techniques which are available to the people, which, many of us are not aware of, for corrosion monitoring? That is
Yes.
the need of the hour, that it is something I don't know. So I would like to know something which is bit innovative, cost effective, and can help the industry to monitor the corrosion and thereby the process safety.
Yes, sir.
Yeah.
Fortunate we are that AI has come to rescue to us, sir. Online real-time corrosion monitoring system has come to the play. Way back in 79, I invited monitoring system in GSFC, and it has been so useful in those years. Now, wireless system, while sitting in your operation room, you know what is the corrosion rate of a distillation column the third batch. You know the corrosivity, what is that. Now, weight loss coupon has become a little outdated thing, sir. Because weight loss coupon is good when batch processes were in use. Now, continuous processes are there. You cannot wait for a year to know the corrosion rate in that. And again, in the weight loss coupon, you never know it is taking pitting corrosion or general corrosion. If it is pitting corrosion, you will not be having a weight loss, but pitting corrosion is very dangerous. By losing few grams, the whole vessel will be useless. So, new technology, as we call OLCM, Online Corrosion Monitoring System. It is the first thing I think most of the chemical process industry should go in. And if any experience, any knowledge required, sir, I am available for that one, if they are interested to do so. I have got certain presentation just to make.
Yeah, please do
Huh? Please, sir.
Sure.
So, difficulties in handling the corrosion issue in chemical process plant. I think what we are discussing, sir, that I have summed up because I was knowing that there are many issues are there which is quite blurred in the mind. We have got many issues in the mind, but we are not in position to touch it. I think after having say 14, 15 slides, people will be having a little more understanding what is corrosion all about, sir. Handling corrosion in chemical process plants is a multifaceted challenge due to the inherent aggressiveness of the chemicals involved and the complexity of the industrial environment. First, variety and complexity of corrosive environment. Chemical process industries. Diverse chemicals. Chemical plants handle a vast array of substances, including strong acids like sulfuric acid, hydrochloric acid, bases like caustic soda, solvents, oxidizing agents like chlorine, hydrogen peroxide, and various organic compounds. This is the first diverse chemicals. Each chemical or a combination of thereof can exhibit unique corrosive behavior towards different materials. Then concentration and temperature variations. The corrosivity of a chemical often depends heavily on its concentration and the operating temperature. A material that withstands a dilute solution at ambient temperature might fail rapidly under concentrated conditions or at elevated temperature. Presence of impurities and byproducts. Process streams often contain impurities, dissolved gases like oxygen, carbon dioxide, hydrogen sulfide, and unexpected byproducts that can significantly influence corrosion rates and mechanisms. Multi-phase systems. Corrosion can be more complex in systems involving liquids, gases, and solids, as each phase can contribute differently to the overall corrosive environment. Then comes diverse forms of corrosion. Chemical plants are susceptible to various types of corrosion, each with its own characteristics and detection methods. For example, uniform corrosion, general thinning of the material surface, which is often predictable, but can lead to overall material loss and eventual failure. Like this we have seen, ugly phase. Then comes localized corrosion. This includes pitting, small deep cavities, crevice corrosion occurring in tight spaces, and galvanic corrosion between dissimilar metals in contact. These forms are often difficult to detect and can cause sudden failure. Like this, you have seen it in the plant. I think you are going back to your plant and can see whatever these ugly faces you have seen in the plant. Then, stress corrosion and cracking. A synergistic effect of tensile stress in a specific corrosive environment leading to brittle fracture. Like this, you have seen it. And Vala has seen many times like this, isn't it? Erosion and corrosion. Material degradation due to the combined effect of corrosive fluid and its high velocity or the presence of abrasive particles. Like this, it is quite known phenomena. Intergranular corrosion. Corrosion along the grain boundaries of metal, weakening its mechanical strength. Like this. These are the ugly faces of the problem what we face always. Then comes the corrosion caused by the MIC, accelerated by the presence and activity of microorganisms. Like this. When you hit excels, you might have seen like this color. It seems like there's copper material, like, isn't it? Copper sulfate like that. Okay. Material selection challenges that we were discussing just now. Finding the right balance. Selecting materials that offer adequate corrosion resistance while being economically feasible and possessing the necessary mechanical properties like strength, weldability, etc. is a constant trade-off. I think we have to cut like this. It is really difficult to remain the balance. No universal material. There is no single material that is immune to all corrosive environments. The optimal choice depends heavily on the specific process conditions. I've come across like this. I think it is unconquerable. It's not possible anywhere, sir. Okay. Few slides. High cost of corrosion-resistant alloys. Materials like stainless steel, nickel-based alloy, and titanium offer excellent corrosion resistance but can be significantly more expensive than carbon steel, which is often preferred for economic reasons despite its lower resistance. And unexpected material degradation. Even seemingly resistant materials can degrade unexpectedly due to unforeseen process conditions or the presence of trace contaminants. And the last, design and fabrication issues. Complex geometries. Equipment with intricate design, such as heat exchangers and reactors, can have areas prone to stagnant flow, crevice formation, and uneven stress distribution, all of which can exacerbate corrosion. I think this type of exchangers which L&T is making, or how much thing you might be passing through, isn't it? Then comes welding and fabrication defects. Improper welding techniques can introduce residual stress and create microstructure changes that make the material more susceptible to corrosion. And then comes, this is a welding procedure, which will never be accepted by anybody. Scale and deposits. Formation of scale, fouling, and deposits on equipment surfaces can create localized corrosive environments and hinder the effectiveness of corrosion inhibitors. Like this, you might have seen the scaling. It has got many effects on the energy loss, surface loss, and under deposit corrosion. Monitoring and inspection difficulties, sir. Accessibility. Many critical areas within a chemical plant, such as the inside of pipes and vessels, are difficult to access for regular inspection. Early detection. Detecting corrosion in its early stages. There is morning we are talking about no ppm, it is now ppt. PPT lies over here. Parts per trillion. Its early stages, before significant damage occurs, can be challenging with traditional inspection methods. Limitations of non-destructive testing. While NDT methods like ultrasonic testing and radiography are valuable, they may not always be effective in detecting all forms of localized corrosion or corrosion under insulation. Continuous monitoring, that is very important, sir. Implementing continuous online corrosion monitoring system can be expensive and require specialized equipment and expertise. Operational and maintenance challenges. Process upsets and changes. Unexpected changes in process parameters like temperature, pressure, flow rate, chemical concentration can alter corrosion rates and mechanisms. Effectiveness of corrosion inhibitors. The effectiveness of corrosion inhibitors can be influenced by various factors and their optimal concentration needs to be carefully controlled. Maintenance cost and downtime. Corrosion-related failures can lead to costly repairs, replacement, and unplanned plant shutdown, impacting productivity and profitability. Human errors. It's very important, sir, which I have come across. Lack of awareness, inadequate training, and improper maintenance procedures can contribute to corrosion problems. Sir, I have a lot of experience with these human factors, how it plays a role. I think this is the last one, sir. Regulatory and environment concerns. Safety hazards. Corrosion can lead to leaks and ruptures, posing significant safety risk to personnel and the environment. Environmental regulations. Chemical plant must comply with stringent environmental regulations regarding emissions and containment of hazardous substances, making effective corrosion control crucial. And this last, I think, disposal of corroded equipment and spent corrosion inhibitors can also present environmental changes. I have tried to cover up all the 360 degrees idea of the corrosion, sir. And addressing these difficulties, this last slide, addressing these difficulties require a comprehensive and proactive corrosion management strategy that integrates careful material selection. I'm using the word careful, not compatible, careful. Many things comes into. Robust design practices. That's why we say, no, corrosion starts at design stage. The human being also starts his design. Who we are at the moment, what our design was at 2 years age, that grows with us. Effective monitoring and inspection programs. And this is what? Optimize operational procedures and continuous improvement efforts. Continuous, as I was telling you, continuously is required. That's all, sir. That's all. Thank you for your presence, sir.
Thank you, Mr. Thanki. I think we will conclude with a few remarks that corrosion is a serious business. I mean, but somehow it is not very popularly considered as a serious business. And I'll tell you, if based on my experience of few decades, that the price which we pay for the abrupt and unknown failures due to corrosion is much, much higher than the price which we will pay in buying an equipment with the better metallurgy. So at the end of the day, we conclude that, we must look at the equipments from the corrosion point of view. The same thing is true for the way it is for the human beings. There is a stress, there is a corrosion, there is a corrosion because of the stress, and there is a stress because of a corrosion. Whether it's an equipment or it's a human being, needs to be monitored on day-to-day basis for both to live a longer life. Thank you.